because we've got all these problems about the Grand Canyon being sediment starved, it's been pretty well figured out that we're trying to patch a leaky cup that's always going to keep leaking in terms of sediment. And the best we can do in an experiment like this is take whatever sediment's in the river from these other tributaries and stir it up and deposit it higher up on the margins. But we still don't have the sediment coming in. And some of the scientists say that we're always going to be losing sediment unless we find some way to augment the sediment. And so there has been some feasibility studies done about actually mining sediment from a nearby tributary, which would most likely be Navajo Canyon, 2 miles upstream of Glen Canyon Dam, and either putting that on barges or in a pipeline and bringing it down and fitting it in. Not really an economic interest, that's going to be a big expense.
It's not going to be a big money maker.
No, it's going to be a money loser, but that's the way to preserve the sediment of the Grand Canyon.
So, is there no concept that would allow any movement of sediment past the dam?
There was a feasibility study that was requested by the Adaptive Management Work Group 4 years ago on the feasibility, the physical feasibility of importing additional sand supplies from upstream sources, meaning the deltaic deposits in various parts of Lake Powell. It was requested by the Adaptive Management Program, the USGS through the GCMRC, the Grand Canyon Monitoring Research Center, undertook that study. It was done by Bureau of Reclamation engineers. The report was finalized in January of 2007. It's available for anybody who's interested to read it. The goal was to see what the feasibility was for importing the equivalent of the average annual input from Korea, about 1 million tons of sand, on an annual basis to kind of double the sand supply. There were 5 scenarios. It was deemed technically feasible with technology that's available today. The cost ranged from $100 to $400 million to construct it, not including environmental compliance activities, and probably on the order of $10 to $15 million a year to effectively operate it, including $90 million a year just for the electricity needed to pump the slurry. And this was from a site relatively close to the dam on Navajo Creek, up and over hill and dale, through a pipeline, and down for injection either into Glen Canyon, the lower part of Glen Canyon, or the upper part of Marble Canyon. And those are the costs. So that report was done. There's been no further effort or movement towards implementation of that. And in the meantime, the scientists haven't declared that they know that without that, this is an impossible strategy or objective. So it's in the library if you're interested. It costs a lot. But it also gives, I think, people a different way to kind of value what we currently more or less are getting for free from Mother Nature, from the Korea River. You could say, well, that's how, if we didn't have the Korea River, how much would it cost to import 1 million tons of sand if that's all we could do? Well, the cost range from $100 to $400 million.